building web applications with resembles, or what I'll just call reason. Before I talk about what that is, my name's Brandon Dail. I work at Formidable Labs. We're a JavaScript consultancy doing a lot of cool stuff with JavaScript like React and Node at scale and open source. So come talk to me if that sounds cool. And I'm a-weary on everything that's important. So we're going to talk about reason and how we can use it to build web apps. But before we do that, I kind of want to set the stage a little bit and kind of get an idea of why I can even ask this question. Like, what has brought us to this stage that we're looking at alternative solutions for web applications? And the first point is that historically, JavaScript has been difficult to scale with. Who uses JavaScript? Cool, you're in the right place then. Who's had trouble using JavaScript? Cool, yeah. So you guys know what I mean. It's a dynamic language. It has a lot of rough edges. The most recent versions with ES6 and ES7 and beyond are making it a really great language, but for the majority, it's just been a little tough. And part of that is it's the only language web browsers support. So even though it's tough to use, you kind of have to use it if you want to build for the web, which is, it's never fun to be forced to do something. And really in the last few years especially, the web is a really growing platform with growing requirements. Your users are going to expect that your web application provides a feature set that's pretty much on par with your native application in a lot of cases. And that's even going to be more and more true as we go. And we've seen in modern JavaScript tooling that the community wants better language level abstractions, right? And the biggest thing we've seen is like Babel. People want to use new abstractions like ES6, ES7, and beyond now. And that means that we're starting to compile our code, right? Compilers are kind of a common part of the modern JavaScript build stack. Who here uses Babel or something like it? Yeah, a lot of people. It's not uncommon. And that's a relatively new change. So we've gotten to the point where we're really trying to compile our problems away. And that's mostly a valid approach. Like I said, compiling is now pretty common. We've come to accept it. You're not going to be outraged by someone compiling their JavaScript. But compiling comes at a cost. And those costs are both abstract and practical, right? Compiling can be slow. It adds complexity to your build system, or adds a build system. Even if you didn't have one before, you have to have one now. And it introduces a layer of indirection between the code that you're writing and the code that you're running, obviously. So we have to make sure that the benefits of this new source language that we're using, whether that's the new versions of JavaScript or an entirely other different language, the benefits outweigh these costs. So to kind of get an idea of how we can judge that, I want to set up a couple points on the criteria we can use to judge that. So this is to really judge, is this new language and compiler worth it? And the first point is accuracy. Right? So the JavaScript compiler has to accurately represent your source abstractions at runtime, right? Like I can write a Haskell to JavaScript compiler in a day if it just compiles to a bunch of console.log calls, right? It's an extreme example, but it kind of illustrates the point that the patterns, they need to be accurate and consistent during, runtime. The new language has to be expressive. We're using a compiler, we're accepting these costs, so the new language should let us express our code better than the original language. So that means we should be able to either use existing patterns and abstractions more clearly or safely or succinctly, or it should provide new ways to express our code, new data structures, control flow, ways to express our intent. Compile time checks. If we're going to use a compiler, we should probably use a compiler that's doing some sort of checking for us, right? For example, like a static type system that checks types. If it's just translating, source code to source code or to target code, then maybe we're not getting the most out of it. Interop. This is huge. The code that it compiles really needs to work with existing code. The JavaScript community is giant. There's, probably thousands of modules, maybe more on NPM and other package managers. The code that we're writing needs to work with those, and it also needs to work with any new JavaScript code, and that goes both ways, right? So we have to be able to call JavaScript from whatever language we're using, and JavaScript has to be able to call whatever our compiler outputs. Debuggability. I wasn't sure if that's a word. It sounds like a word. So no matter how good our compile time checks or the language abstractions are, we're probably going to have to debug at runtime. Even if you have something that guarantees no runtime type exceptions or exceptions at all, like Elm, you still might have an issue that's not necessarily related to an exception. You might have a logical error that you need to debug at runtime. And if that's difficult or impossible, you might be losing out. Junior friendly, and this is really a point more in the context of the community and community adoption rather than in a specific implementation or application. But if we're going to talk about using a new language and adopting a new language, we want to make sure that it's accessible to everybody in the community, right? Because adoption is affected by how accessible a language is. If there are features of the language or limitations of the language that limit that, no matter how great those abstractions or limitations may be, we have to consider that as a potential downside. So what do I propose? I listed a bunch of stuff. What are our options? And my proposal here is going to involve 3 technologies. First, OCaml, which is going to provide the semantics. It's a programming language. Who here has used OCaml? Oh, cool. A lot of people. It's been mostly used in academia for a long time and in some sort of niche, or not maybe niche, but smaller industries like finance. We're also going to talk about using reason, which is a new syntax for OCaml, and also sort of a tool chain, as the logo says. And then we're going to talk about buckle script, which is what's going to let us actually use reason in OCaml for the web. So I'm going to talk about these kind of out of order. But just a quick overview of OCaml, for those of you who haven't used it. It is a dialect of the ML language family. So ML, I think other dialects like standard ML. Very functional. Developed by INRIA, I think that's how they pronounce it, which is the French Institute for Research in Computer Science and Automation. And it first appeared in 1996, actually a year after JavaScript, interestingly enough. It is multi-paradigm, so OCaml is mainly used as a functional language, but it also supports imperative and object-oriented programming, so it's pretty flexible. And it's popular with finance, so Jane Street, who's actually sponsoring, uses it pretty much exclusively as far as I know, and Unikernels, MirageOS is an example of an OCaml project. And then there's Reason, and Reason is much newer. It's a product of Facebook, but it provides a more familiar interface for users who might not be familiar with ML or its variants. It uses OCaml's PPX system, which is part of the compiler, I believe, that basically lets you hook into compilation sort of at the AST level and transform the syntax, which is how Reason even is allowed to work. And it's also meant to provide a lot of tooling. And I'll go over the more specific aspects of the tooling that it provides in a little later. But first, I want to talk about the language itself for those who haven't actually used it or are not sure what it provides. And so keep in mind that when I talk about the language, I might say Reason or OCaml interchangeably, but the language itself is OCaml, and Reason is just the interface in this context. So if I use those interchangeably, I hope it's not confusing. If I'm talking about something specific to Reason, like what it provides, I'll try to make that explicit. So first off, some basics. Let bindings and scoping. So to define a variable, you use let. Bindings are block scope. So here we define a full name, and we assign its value to a block that defines a couple local variables, Brandon Dail, and then the last statement in the expression is the value of the expression. So full name ends up being Brandon Dail. So the type system is really powerful, and it's pretty complex to the point that I probably can't cover a lot of it in this talk. But basically, you have type annotations, just like most statically typed languages, but it also has a powerful type inference system, which is one of the biggest features of ML languages. They have really great type inference, so it's a powerful type system that rarely gets in the way. It also supports algebraic data types, or ADTs. Here we define a vector of ints, and it has parametric polymorphism, so we can sort of define generics. In this case, we have a generic vector type. So talking more about ADTs, we have a construct called a variant, which might be called disjoint unions, some type, discriminated unions, all basically the same idea here. And it lets us represent sort of heterogeneous data in a type-safe way. And here we define a color variant with red, blue, yellow, and other. These are all type constructors. And note that other takes an argument, which in this case is a string. So variants can actually hold data in a way that can be accessed at a later time. Then we have records, pretty basic, just key value pairs. This is a user record as a handle that's a string, ID that's in it, and then we're using that color variant that we just defined previously, pretty basic. And these are immutable by default. It does support mutable fields, which we'll talk about a little later. One of the greatest things about the language is its pattern matching system. So here's an example of using pattern matching with variants. And pattern matching is pretty pervasive in the language. And in this case, we are defining a function called hex, which takes a color, which is of the type color that we defined earlier. And we're using the switch statement to switch over it and handle all the cases for that variant. And we can see here that pattern matching lets us sort of extract the data from a type constructor, specifically other. We're getting that string value, which we assume is a hex value for the color, and returning it. But really the best thing about pattern matching here is that it's exhaustive. So if I forgot to match blue, for example, the compiler would give me a warning that the pattern matching is not exhaustive. And then it actually gives you an example of a pattern that you forgot to match. So this is really useful, and it also applies to pattern matching with other data types like lists. So here's an example of a recursive function that sums up a list of numbers, and we can see that we're using a switch statement again to pattern match the list. And when it's an empty array, we just return 0. Otherwise, we add it and recursively sum up the tail of the list. So it's a great way to handle sort of abstract or like compound data, like lists or variants. And of course, OCaml mainly uses a functional language, so the functions are pretty functional. Here are just a few of sort of the main points that you get. You have currying and partial application, pattern matching, specifically with a function keyword, so functions can be defined specifically for pattern matching. You get labeled arguments, and you also get optional arguments with optional default values as well. And then modules. So to paraphrase from probably one of the best books on OCaml, Real World OCaml, OCaml is almost two languages. A core language concerned with values and types, and then sort of a module language concerned with modules and module signatures. So modules are a huge part of OCaml, and they're really powerful. But basically, every file is a module by default. Modules can contain other modules, so you can define submodules. You can define specific and explicit interfaces for modules in a separate file, like called an REI file. So you can limit sort of the API for the actual module. We have functors, which in the context of OCaml are basically like parameterized functions for modules, basically, that lets you operate on modules and return augmented or new modules. And then we have a concept called first-class modules, which lets you sort of compact a module into a concrete value, so you can use it with sort of variable bindings as well, which usually isn't possible. And here's just a small example of a module. It's a user. It contains a type T, which is a variant of basic user, moderator, admin, and then a function for getting some sort of title from the user, again using pattern matching. So like I said, it's a functional language, but it also supports imperative APIs. So we have mutable arrays. We have arrays that we can sort of edit in place. We have mutable record fields. And again, mutable fields have to be defined explicitly. By default, record fields are immutable. We have these things called refs, which are basically sugar for mutable record fields, which kind of let you define a mutable value. And then we have imperative loops. We have for loops, while loops. So while OCaml is heavily used as a functional language, it can be used imperatively. It also has a pretty great object-oriented system with objects, classes, inheritance, all that kind of stuff. But moving on, I want to talk a little bit about reason specifically. So reason does provide a syntax that makes OCaml a bit more familiar, but it also provides tools that make it easier to use. And one of the best tools is what's called reason format or reformat. And I'll see if it plays. It's supposed to be a GIF. Oh gosh. No, it's not a GIF. It's not working, but it's a GIF, trust me. So reformat basically is a formatter for reasons, so you don't really have to think about formatting your code. If you've heard of Prettier for JavaScript, it's what inspired Prettier. And it does a lot of great things beyond just sort of basic formatting. It can identify, optimal constructs for your code. For example, if you try to do a pattern match on just a true or false value, it can automatically update that to sort of a ternary expression. So it works, again, beyond just basic formatting. There's also this thing called Reason Tools, which is a browser extension. And what it lets you do is it lets you visit any sort of resource that's written for OCaml, and then automatically or explicitly convert that code or code snippets over to Reason, which is really useful because a lot of the documentation out there or tutorials for the language are written with just the plain OCaml syntax, which makes sense because Reason's only been around so long and OCaml's been here for 20 plus years. Better errors. This is something that's a work in progress, but I think it's going to make Reason even more attractive, and it's already working pretty well. So if you've ever used Elm, you've probably seen that they have really great error messages. If you've ever used Reason, the error messages really, they're good, but they're not as good. So better errors is an effort to make them even better, as the name suggests. Basically here we have an error about an optional argument. So yeah. A work in progress, but it's upcoming. And really one of the most important things that Reason is providing us, which is even more than part of the tool chain, is what's called Reason React. And it provides an API for writing React components using idiomatic patterns in Reason, and lets you bind to the React library. So you can write React applications in Reason. And I want to walk through an example of using Reason React. And note that this is the new Reason React API, which was released last week or the week before. So if you see any other examples online that look way different, I promise I didn't make this up. It's just kind of new. But I want to step through this to give you an idea of what the API looks like. So starting at the top, we define a component template using this method called stateful component, which takes a string, which is basically the name of the component, kind of like display name in React. Really useful for debugging. And this component template we use to actually make the component. And speaking of make, we define a function called make, which is what Reason React will call to actually instantiate the component. And each prop for the component is defined as a labeled argument. So this component greeting takes one prop name. And the last argument has to be the children for the component. If you don't have any children, you can ignore the argument using the underscore, which is what we're doing here, which tells the compiler that it's an unused argument. So then we define a click handler. And this is an event handler for a click event. And we can see that it takes an event, which is the click event, the component state, and then this self record, which I'll talk about a little later. And you can see we're ignoring event and self, and we're just using state. And the interesting part here is that we're explicitly returning the update. So if you've used React before, you know that setting state is usually sort of an imperative API. You call this .setState to tell you what the next state is. In this case, methods actually just return the next state or whatever update they're making. And here we're updating the state by incrementing it by 1. Speaking of state, we have to define our initial state, which is just a function that returns our initial state. And note that in Reason React, your state can be any value, as opposed to regular React where it has to be an object. So it's kind of useful. And here we're just using a number, 0. And then we have a render function, very similar to just React and JavaScript. And it takes the state for the component, as well as this self record again. Let's look really closely here at what's happening in render, though. First, we're just creating a string, which is a greeting, using concatenation. And then we're rendering it as an h1 tag. And it's interesting to note here that we have to explicitly convert the string to an element. as opposed to regular React where you could just return a string or a number or whatever. And it might be a little bit more verbose, but it does demonstrate how Reason React lets you write React components in a more type-safe way by default. There are other conversion methods like array to element for like arrays and null element for returning null. And then we're actually using that click event handler that we defined earlier. And this is where we actually use self. We're passing that method to this update function that is on the self record. And update takes a function and returns another function that has access to state and actually returns the update type. So it kind of takes the place of bind, which you usually have to do in regular React. So there's no sort of concept of this, this.setState or this.state in Reason React. But really the coolest thing about this that I skimmed over is that we're actually still using JSX here. And we're not using Babel or any other compiler other than Reason to do so, because Reason has native support for JSX, which means that we can use it without any additional configuration or setup. And what it basically does, JSX in Reason looks something like that. And then that's basically sugar for this function call, where you call this div function, where the props, again, are arguments to the function. And then it adds this JSX attribute, which is part of the PPX compiler, which Reason then hooks into again, and then compiles it to this function call, which I hope you can see at the bottom, basically calls create element with the name of the element. And it's important to note that when you use a composite component, like the one that we just defined, it'll compile it to a call to that make function that we defined. Which is pretty cool. So going back to our criteria, how does Reason and OCaml stand up? And I've grayed out the option or the categories that are kind of related to the compiler. But starting with expressiveness, I think we can see that OCaml is very expressive, especially compared to JavaScript. It has a great module system with explicit boundaries. It has a static type system with really great inference, multi-argument create functions, all of that stuff. It also has imperative coding or APIs. So even though we can use these functional APIs and constructs, we're still working with the JavaScript ecosystem. So being able to use those imperative code paths is really important. So for compile time checks, I think we can pretty much agree that that's also green. We have a really great type system again. ML is known for its type inference and the soundness of its type system, so we're getting a really safe language. And then junior friendly. I think this is something that Reason really provides. It makes OCaml accessible to developers in the JavaScript community, or at least more accessible. Not only by providing a syntax that's easier to understand for someone with that background, but also by making the tool chain a little bit easier to work with. But we do have to take a step back, because unfortunately we can't do this. Browsers have no idea what Reason or OCaml is for the most part, and will probably never will. So we do have to circle back here and talk about the compiler, because without it, even though it's a great language, we wouldn't really be able to use it for web applications. So again, the compiler that we're using is what's called BuckleScript. And BuckleScript is a backend for OCaml that outputs JavaScript. It's developed by Bloomberg, specifically one developer, Bob Zhang. It has native support for Reason, which is really great. That means you can use BuckleScript without actually configuring any additional support for Reason or anything like that. It will recognize a Reason file and automatically compile it. It has high-quality dead code elimination. So it does dead code elimination sort of at the function and module level. And it also does a lot of things like inlining. So the outputted code is usually very sleek. Extremely fast compilation. This is something that I wish I had more concrete numbers on. I tried to find sort of benchmarks or run benchmarks, but unfortunately I couldn't. But BuckleScript has, time and time again, showed to be an extremely fast compiler. OCaml is already known to have a pretty fast compiler relative to other languages at similar sort of levels. And BuckleScript is no exception. it is much faster than Babel and TypeScript for sure, and in my experience faster than other languages too, like Elm or PureScript. It has no heavy runtime, and in a lot of cases, you can write code that has no runtime at all. So there's no inherent runtime with BuckleScript that has to be included. The code that it outputs can usually run on its own, standalone. It might input, or it might import some utilities for things like type conversions that need to happen at runtime, but otherwise, it's pretty sleek. And like I said, it is possible to write code that avoids those imports. And it has a really expressive FFI, foreign function interface. So it lets you bind to things like objects, dynamic property access, functions, uncurried callbacks, modules. There's a number of things that make it really easy to use as well. So let's look at a quick example of the language, or I'm sorry, of the compiler output. Here's an example of that I pulled from the BuckleScript docs. It's just using basically the HTTP library from Node, and it's creating a server. And note that this is the ML variant, so this isn't actually using reason. This is just regular OCaml. But we can see that what it outputs is actually very close to what the source code looks like. There's very little here that would indicate that the code was generated by a compiler, other than sort of comments and that pervasives import that's used for, like I said, runtime type conversions. But if, like I said, there's no inherent runtime, but if you do end up importing something from BS Platform, which we have here, pervasives, it is usually very lean. All of the standard library that it has or its runtime is written in OCaml and compiled to JavaScript, so you get all the benefits of BuckleScript there as well. And combined with like a JavaScript bundler like Webpack or Rollup that does tree shaking, you'll end up with very minimal overhead in almost all cases. So getting started with BuckleScript is super easy now. Really all you have to do is npm install this BS platform, which is the package for BuckleScript. And then it installs this global utility BSB. And when you want to make an application that uses BuckleScript, you just call it with the init option, give it the name of your application, and it will set everything up for you, including getting the BuckleScript binary, set up a node module, setting up a package JSON, all that. And it even recently introduced a feature called themes, where you can initialize a project from an existing template, such as a Reason React project. So that'll continue to grow and make it really easy to use BuckleScript in a lot of contexts in the JavaScript community. So circling back to hit all of our points, how does BuckleScript with Reason look? First, starting with accuracy, BuckleScript provides really not only an accurate representation of our source program, but it does so in an idiomatic way. The outputted code is almost always readable by humans. I would say always, and it's usually well structured. For interop, I didn't get to actually show any examples of BuckleScript's FFI API, but it is very complete. And like I said, it has bindings for functions, values, modules, getters, setters, all of that kind of stuff. And since the code is often very well structured, and BuckleScript respects any interface files you defined, like those REI files for modules, there's really no overhead for calling functions compiled by BuckleScript from any other JavaScript code. It'll just export what you defined. So it's really a module-to-module compiler. For debuggability, this again does go back to accuracy. BuckleScript does a great job of outputting code that is really well structured. So stepping through it at runtime is usually non-trivial. There's very little difficulty understanding what's going on. Oh, it's not moving. So the question arises, is it time to jump ship? Should we delete all of our JavaScript, start all of our new projects in Reason, call up our boss and tell them that we're going to start migrating now? I want to say yes, but probably not. And don't ever run that command. That's probably a bad idea. I do highly recommend using Reason and experimenting with it when you can. But it is important that we try to identify all of the rough edges so that we can kind of make an informed decision about, how well it works for us. And also so that we know what the rough edges are and we can help smooth them out. So let's try to identify them. The biggest issue that I've had is that most learning resources use regular OCaml syntax. If you know OCaml, that's really not a barrier for you. But again, we're talking about using the language in the JavaScript community. So we want, and again, we have Reason, which makes OCaml more accessible. So we want resources that will also be accessible. This is something that isn't inherent to the language or the platform or anything, so it'll get better over time. But right now, it's a little difficult if you don't know OCaml, because you have to go between them and sort of, you have to learn the language and a different syntax at the same time, which is a little tough. The build tooling is in flux. It's pretty stable, especially if you just want to write web applications or just native applications. But a lot of the times, you might want to write applications that run on both. And that's one of the other great things about OCaml is that it has, of course, a native compiler. So you can compile your application to native code. And the idea is that eventually you'll be able to have a shared code base for your web application and your native application. But it is in flux, but under active development. So it is as well getting better. And like I said, targeting native and web isn't as easy as it could be. Which, if you're just doing web, this might not be an issue for you. Error messaging isn't as good as alternatives like Elm just yet. I did show better errors earlier, but it's a work in progress, and it's not yet at the same level as Elm, getting close, and hopefully someday it will be. And I believe it will. As far as Reason goes, there is limited use in production outside of Facebook, who's developing Reason. OCaml itself has been used in a lot of contexts over the last 20 years and has shown itself to be a pretty proven technology and language. But Reason and BuckleScript have only really been around for at least a couple years, and the adoption is sort of rising, which means you're an early adopter, which inherently means that there's high risk, high reward. There's no guarantee, again, that it will continue to have the support that it has. The community around it is building, and I believe it's getting stronger and stronger, and I hope all of you participate in it. But again, it's important to realize that it is a new technology as far as BuckleScript and Reason for the web. And that's it. Thank you for listening. Here's a couple more resources. Oh, I guess it wanted to stop. The docs for Reason, the docs for BuckleScript, and then there is a really active Discord channel, which I highly recommend joining, where the community talks and even the creators of Reason are very responsive. But yeah, that's it.
How much of the OCaml compiler is the setup actually using? Do you have a new parser and new backend? Or is it too much in between?
So do you mean like how, I'm sorry, can you repeat that?
Okay, like this setup uses like another parser for OCaml and like another backend. So like how much in the middle is it actually using from the compiler?
I'm not specifically sure how much, you mean like how much BuckleScript and Reason are using?
No, how much of the OCaml compiler is used?
Well, Reason uses the PPX system that the OCaml compiler supports, so it lets you hook in and respond to attributes. And so does BuckleScript. You can add annotations, which is how the foreign function interface works. I'm not specifically sure to what extent BuckleScript hooks into the existing compiler or at what level, but I know Reason, again, is mainly using PPX. That answers your question. I'm not sure.
I hope they use the OCaml type checker.
Oh, right, yeah. It's the existing, I think it's OCaml, it's a specific OCaml version 4.0.2 or 3 or something like that. So it is using like the type checker and stuff. BuckleScript or Reason, they don't have their own type checking system. So all of the, again, the language itself is OCaml. So all the language features are compiled or run through the OCaml compiler. It's really just a syntax for the interface and then a backend for the compiler, BuckleScript, which outputs JavaScript. yeah.
Other questions?
I saw there's some React Native binding someone's working on for reason. Have you tried to use that?
I haven't tried to use that, and I can't speak to the maturity of those yet. I know that there are a lot of people working on it, and that it is, I believe, a goal to be able to write sort of universal React code, right? React for web and React Native. So it's something that's probably going to be very actively worked on at some point.
So what about if you have an existing project in JavaScript, is there a good way to like go over to reason in steps?
Yeah, that's actually one of the biggest advantages. The question again is, if you have an existing JavaScript project, how can you integrate with Reason? And because BuckleScript works sort of module by module, you don't have to compile a whole program at once. You can move over, and JavaScript projects nowadays are pretty much written in modules, right? You have various modules that export various things. So you can move it over module by module, and then just adjust your other existing JavaScript modules to import the compiled JavaScript files instead of whatever original JavaScript file. So you compile it and then just import it. And like I said, BuckleScript does respect like interface files, so you can define explicitly what's exported, and you can also make sure that the functions, for example, that it exports are easily usable in JavaScript. So in OCaml, like all functions are curried by default, right? And in JavaScript, that would look really weird because you'd have to like call a function, then call a function. So you can define, you can explicitly say, hey, I want this function to be uncurried, which makes it really easy to call from other existing JavaScript code.
So you're talking very objectively. Can I ask you what's your personal experience with it? And either if you're coming from a JavaScript or ML background?
Yeah. So yeah. So the question is like, what's my personal sort of opinion here, or what's my background, and how do I feel about it personally? So I'm a JavaScript developer, and I haven't really used a lot of languages like OCaml in production or anything like that. So coming from JavaScript to OCaml has been, I think, as far as usage goes, a pleasure for me because I see the advantages of static typing is very extent. I've used other static type systems like Flow, if you've used that, or TypeScript in JavaScript. So using the language has been really great. And I think the type inference really lets you use it without the type system getting in the way. Of course, that's the whole idea of type inference. So it's been really easy for me, I believe. But going back to sort of the rough edges, what's been hard for me personally is that the learning resources, again, are pretty fragmented. So if you don't know OCaml, and if you're not familiar with it, you have to learn OCaml, and then you also have to learn Reason, which is kind of a syntax for it. So that's getting better. There are more resources being written for the language, but it's kind of a tough point right now.
Last question. Before lunch.
You mentioned beginner friendliness as a reason for having reason. What is a perceived problem with regular OCaml that it's trying to solve?
Right. So Reason does a lot of things that make the syntax, I guess, more familiar to JavaScript developers. And that's not to say that Reason is specifically targeting JavaScript developers, but I think it is at least partially a goal. So for example, like in OCaml, you have like, you have to use like in for scoping. In JavaScript, you just have block scoping, and that's what Reason provides. And using basically similar syntax. Like, arrow functions are in ES6, and OCaml has them, but they're a little syntactically different. So I think as far as syntax goes, it makes the language a little more accessible to people who aren't familiar with ML or sort of functional languages. Maybe coming from another background like JavaScript or a language like JavaScript. And then I think the alternative goal is that the path to using OCaml for the web specifically with BuckleScript was a little rough. before. So the Reason team and the BuckleScript team, they do work pretty closely to try to integrate that. So that's part of sort of the tool chain effort, making it easy to set up, get started, or start using Reason for the web. Thank you. Application provides a feature set that's pretty much on par with your native application in a lot of cases, and that's even going to be more and more true, as we go. And we've seen in modern JavaScript tooling that the community wants better language level abstractions, right? And the biggest thing we've seen is like Babel. People want to use new abstractions like ES6, ES7, and beyond now, and that means that we're starting to compile our code, right? Compilers are kind of a common part of the modern JavaScript build stack. Who here uses Babel or something like it? Yeah, a lot of people. It's not uncommon. And that's a relatively new change. So we've gotten to the point where we're really trying to compile our problems away. And that's mostly a valid approach. Like I said, compiling web applications with Reason ML, or what I'll just call Reason. Before I talk about what that is, my name's Brandon Dail. I work at Formidable Labs. We're a JavaScript consultancy doing a lot of cool stuff with JavaScript like React and Node at scale and open source. So come talk to me if that sounds cool. And I'm a-weary on everything that's important. So we're going to talk about Reason and how we can use it to build web apps. But before we do that, I kind of want to set the stage a little bit and kind of get an idea of why I can even ask this question. Like, what has brought us to this stage that we're looking at alternative solutions for web applications? Is now pretty common. We've come to accept it. You're not going to be outraged by someone compiling their JavaScript. But compiling comes at a cost. And those costs are both abstract and practical, right? Compiling can be slow. It adds complexity to your build system, or adds a build system. Even if you didn't have one before, you have to have one now. And it introduces a layer of indirection between the code that you're writing and the code that you're running, obviously. So we have to make sure that the benefits of this new source language that we're using, whether that's the new versions of JavaScript or an entirely other different language, the benefits outweigh these costs. So to kind of get an idea of how we can judge that, I want to set up a couple points on the criteria we can use to judge that. So this is truly judged. And the first point is that historically JavaScript has been difficult to scale with. Who uses JavaScript? Cool, you're in the right place then. Who's had trouble using JavaScript? Cool, yeah. So you guys know what I mean. It's a dynamic language. It has a lot of rough edges. The most recent versions with ES6 and ES7 and beyond are making it a really great language, but for the majority, it's just been a little tough. And part of that is it's the only language web browsers support. So even though it's tough to use, you kind of have to use it if you want to build for the web, which is, it's never fun to be forced to do something. And really in the last few years especially, the web is a really growing platform with growing requirements. Your users are going to expect that your web app, is this new language and compiler worth it? And the first point is accuracy. Right? So the JavaScript compiler has to accurately represent your source abstractions at runtime, right? Like I can write a Haskell to JavaScript compiler in a day if it just compiles to a bunch of console.log calls, right? It's an extreme example, but it kind of illustrates the point that the patterns, they need to be accurate and consistent during, runtime. The new language has to be expressive. We're using a compiler, we're accepting these costs, so the new language should let us express our code better than the original language. So that means we should be able to either use existing patterns and abstractions more clearly or safely or succinctly, or it should provide new ways to express our code, new